This video will help you with lesson 1.05, graphing transformations. It's very important that you take this particular lesson very seriously because graphing transformations, the rules that you're going to learn are the exact same from all different types of graphs. So if you understand how to do it, the more advanced and complex sections might be just a little bit easier. So let's go ahead and take a look at this one. So the first thing we're going to do here is we're going to describe the graph of the following functions. So what we're going to look at is what happened from this guy to this guy. So I began with x squared, and I ended up with x squared plus 4. So we probably noticed that I added 4 to it. So because the plus 4 is on the outside and it's by itself, that means it is a vertical, get the L in there, translation. Some people also call it a vertical shift. Both are appropriate, but the key word that you know is that it's vertical. So it's meaning it's going up or it's going down. Because it's positive, that means it went up 4. So you might see something where it says you translated f of x up 4 units. That's just a fancy way to say it. There are a couple ways you're going to see the phrasing of it, but it's the same idea. I went up 4 units, I translated it 4 units to the positive, up the y-axis, all different ways you can probably say it, but it's the same idea. So if the number is by itself here on the outside, then it is a vertical. If it's positive, it went up, and if it's negative, it went down. Now take a look at this one. You had x squared originally, and then you went to x plus 9 squared. So again, I added something to the x, but what's different about this one than the last one is that I added it inside the parentheses. When it's inside the parentheses, it's going to be a horizontal translation, or again, a shift, okay? Remember how in the first video, if you watched it, I told you to pay very close attention to that vertex form. Because if you memorize this and just understand it, it's going to make some of this other stuff very easy. Because with horizontal, if you think about it, this right here, this is your horizontal stuff that we're talking about here. That's that shift. The plus k, that's the plus 4 we just did on the last video. The reason I'm telling you this is because you see minus h in there. It's already minus. So what you're looking for is what happened. So here you see plus 9. And a lot of people think that means it went 9 units to the right. Well, it didn't. It actually went to the left 9 units. And the reason is, again, this formula is already a negative. So if you all of a sudden in yours have a plus, that means you must have put in a negative 9. So my h value actually was negative 9, meaning I went 9 to the left. A great way to remember that as a just kind of a memory trick is when it comes to horizontal, it's always the opposite of what you would naturally think. You see plus 9, you think horizontal, you think, oh, I'm going to go to the right. Well, you're not. You're going to do the opposite of what you think. So you're going to actually go to the left 9 units. So be very careful. It's a very common mistake. On this one, look at what happened here. I got a minus 9 in the parentheses. So that's a horizontal, but it's minus. So you would naturally think it went 9 to the left. Well, it didn't. Remember, it went to the right 9 units. Then I've also got a plus 4. And we know that that's positive, so it also went up 4 units. So when I'm describing this transformation, I would say, maybe something like translated 9 units to the right and 4 units up, something like that. So a transformation can be more than just one thing. Several things can happen to it. Now notice on this one, I got radical x and then negative radical negative x. If the negative occurs, that means there's what's called a reflection. okay? So a reflection occurs. So if the negative is on the outside of the radical or parentheses, it could be as simple as, it could also be something like an absolute value. These rules still apply. So that's what I was saying earlier. If you can really grasp this, the rest of it's going to be fairly easy when you get to the more complex types of graphs. So now, if it's on the outside, that means it is a vertical reflection. Okay? Anything on the inside, the same way we did with the parentheses, now it's a radical. It could be an absolute value. All that would be a horizontal reflection. But I want to show you what that means when you're referring to the actual graph. If you were to, for example, say this, and let's say I just have a parabola right here. All right, let me change my colors so you can kind of get a better idea of what I'm talking about. If I want to do first, the very first thing from left to right, we read it left to right, is a vertical reflection. So it's going to reflect vertically. Vertically is, remember, is your y-axis. So that means that it's going to reflect and come down here. So when you're describing that, you may have to say reflects across x-axis. Although vertically, you think y, and you're right, but to make a vertical translation, it has to actually reflect across the x-axis. So let me change colors again so you can see the second move that it does. Let's make it kind of an orangey color. So first I did the vertical reflection, which was when I reflected across the x-axis. And then I'm going to do a horizontal reflection, which again, you would think x, which is true. But when you make that reflection, it'll end up here. And again, these are rough drawings. But that reflection would then go across the y-axis to describe where that graph goes. So in this particular one, it was a vertical reflection and then a horizontal reflection. On the graph, that means you reflected it across the x-axis first and then across the y-axis. Just be careful in the way that you describe those, but those are reflections. So here, notice what happened. I've got a negative sign, so that to me indicates reflection. It's on the outside, so I know it's vertical. Nothing happened inside, so I would just say that it reflected, or reflection, across the, since it's vertical, it will go across the x-axis. So here, same thing. No negative in the front. There is a negative here, so that means that there is a reflection, and it is a horizontal one because it's inside. So I would say that this one, when I'm describing it, I would say reflection across y-axis. And now I've described that one. And that should be all the information that you need to do well on this inverse function. I wish you good luck, and we'll see you in the next set of videos.